Measurements has been one of the most important aspects in the world of physics. It allows us to gain a deeper understanding of the dimensions of certain objects around us. How cool would it be to find out the densities of certain objects in our daily life?
These are the following objects that we are going to measure its density with the equipment. This is a book, which is an regular object, a sharpener, which is an irregular object, and a special object.
Cool. First of all, we are going to find out the density of this regular object. This regular object is a book. It's regular in shape, so we can use conventional formula to find out its volume. In order to find out its volume, we have to use the meter ruler. This is called the meter ruler. And we can use this meter ruler to find the length, breadth, and height of this book. So, first of all, we are going to find the length of the book. As you can see, the length of the book is I'm taking the reading from the 3rd cm mark, and it ends at the 13.5 cm mark. This shows that the length of the book is, the breadth of the book is 13.5 minus 3 cm, which equates to 10.5 cm. Next, we have to find the height of the book. In order to do this, we have to use the vernier caliper, as the height of the book is very short. This vernier caliper has a precaution. The precaution is to correct for the zero error. In this vernier caliper, there is no zero error when you fully close both of the jaws. Hence, zero error is 0.00 cm. Now we have to find the height of the book. Open up the vernier caliper jaw fully, clamp it tightly, but not too tight on the height of the book, the spine. Okay, now I'm going to take it out. The height of the book can be read as 25.2 mm. 25.2 mm. This is the height of the book, but when converted to cm, it is 2.52 cm. So now, the breadth of the book is 10.5 cm, the height of the book is 2.52 cm. Now, we have to find the length of the book. We have to use the meter ruler to find the length of the book, as the length is long. The length of the book, when using the meter ruler, I'm using the 3rd cm scale again. The length of the book can be read as 20 minus 3 cm, 17 cm. So we have found out the length 17 cm, the breadth 10.5 cm, and the height 2.52 cm. Now it's possible to us to find the volume of the book by using length times breadth times height of a cuboidal object.
Now we are going to find the mass of the book. The first step is to correct the error on the scale. Now put the object on the weighing scale. Reads 180.9 grams.
Now we have found the volume of the book. The volume of the book is 449.82 cm cubed. We have just found out the mass of the object in grams, which is 180.9 grams. Using the formula mass over volume equals to density, 180.9 grams over 449.82 cm square, the cube, will result in a density of 2.49 grams per cm cube. This is the overall density of this book. Next, we're going to find out the density of this sharpener. In order to find the density of this sharpener, we have to find the volume of this sharpener. This sharpener is an irregular object. Hence, the volume cannot be found using conventional formula. Hence, what we have to do to find the volume of this sharpener is to use the Eureka can method. First, fill up the Eureka can up to the point where the water starts to leak out. This point inside here.
Hey, Sabby, Joshua.
Yes, right.
I'm filling it up.
This one, right? Okay. So this one is you do it very you must do it fast. Yeah, this one must use Eureka can one. So this big.
Now, I filled it up the water level to the point of the opening here. Now, we have to ensure that we do not fill up water above the point opening here, as water may leak out. Next, using the measuring cylinder, we are going to collect the displaced water, which is the ultimate volume of the sharpener. Now, thank you. I'm going to let this object go gently into the water. Now, we have collected the displaced water in this measuring cylinder. We have to avoid parallax error when using the measuring cylinder, as the meniscus of the water may confuse us. According to the recording here, it states that the water level is 40 cm, is 44 cm cube. Now, we have known the volume of the sharpener. Now we have to find the mass of the sharpener.
Now to find the mass of the sharpener. Same thing goes for the electronic balance. We start the 0. Now place the sharpener on the weighing scale. Yes, I got it out. It reads 47.2 grams.
Now, the volume of this sharpener is 44 cm cube. We have just found the mass of this sharpener, which is 47.2 grams. Now, using the formula mass over volume equals to density, we have found out the density of this sharpener, which is 1.07 grams per cm cube. Now, we are going to find the volume of this pen. This pen is an irregular object. It's our special object. And so, we're going to find the volume of this pen using the measuring cylinder method. So first, we have filled up water to the 60 cm cube mark. We're going to drop this pen gently into this beaker to find the displaced amount of water, which is the overall volume of the object. Now, this is how we drop it. Slowly into. Now, the new volume is roughly around 70 cm cube. This shows that the displaced water is 70 minus 60 cm cube, which is 10 cm cube. That is the volume of this pen.
Now to find the mass of this pen. First, correct the electronic weighing scale to 0. Now, place the pen over the scale. It reads around 9.0 grams.
The volume of this pen is therefore 10 cm cube. We have just found the mass, which is 9 grams. Now, in order to find the density, use the formula mass over volume equals to density, which ultimately results in the density of this pen being 0.9 grams per cm cube. So we have found out the overall densities of these three objects. The density of the book is 2.49 gram per cm cube. Density of the sharpener is 1.07 grams per cm cube, whereas the density of the pen is 0.9 gram per cm cube. This shows that the most densest object here is the book, followed by the sharpener, and the least densest object here is the pen. Thank you all for watching our video, and we hope you gain a better understanding of the topic of measurements.